Welcome to the mathematics in my channel. Today we are going to solve another interesting integral from 0 to pi over 2 natural log of cotangent of x square dx. Okay, how to begin? Well, I like to use beta function and gamma function, so I selected to solve this method. So I'm going to define an integral from 0 to pi over 2 cotangent of x raised to the n power uh, dx. Okay, we know we can write this is equal to 0 to pi over 2 here, cosine to the n power of x over sine to the n power of x dx, and now 0 to pi over 2 here we can write sine raised to the minus n power of x times cosine to the n power of x dx. Okay, now we know we can use gamma function. We know gamma function 2 times 0 to pi over 2 sine raised to the 2a minus 1 of x times cosine raised to the 2b minus 1 of x dx is equal to beta of a b. So now here we can write this integral by using beta function. So here now we should find the a and b, so we can write here 2a minus 1 is equal to here minus n, so 2a is equal to 1 minus n and a is equal to 1 minus n over 2. Also we know n is equal to 2b minus 1, so 2b is equal to 1 minus n and b is equal to 1 minus n over 2. So we can write here this is equal, now here 2, so 1/2 times beta of 1 minus n over 2 1 sorry here 1 plus n over 2, so 1 plus n over 2. Now we know beta function, the formula of beta function by using gamma function. Beta of ab is equal to gamma of a gamma of b over gamma of a plus b. So we can write now here 1/2 times gamma of 1 minus n over 2 gamma of 1 plus n over 2 over gamma of a plus b. We know if we take sum of these terms, this is equal to 1, and gamma of 1 we know 1. So now we have 1/2 times gamma of 1 minus n over 2 1 plus n over 2. So we know now we can use Euler's reflection formula. We know Euler's reflection formula, gamma of c gamma of 1 minus c is equal to pi over sine of pi c. Okay, now I'm going to take a substitution. So if we take c is equal to n plus 1 over 2, so we can write now gamma of n plus 1 over 2 times gamma of 1 minus n plus 1 over 2. We know 1 minus n over 2 is equal to here pi over now sine of pi times n plus 1 over 2. So sine of pi over 2 times n plus 1 over 2. So we know this is equal to cosine of n pi over 2. So cosine of n pi over 2. Okay, then we can write 0 to pi over 2 cotangent raised to the n power of x dx is equal to 1/2 times here pi so we can write pi here. So pi over 2, instead of cosine we can use secant. So secant of n pi over 2. Well, now our question, natural log of cot x. So we know now we can use differentiation. So if we differentiate with respect to n, so now I am going to use differentiate with respect to n, because we have natural log of cotangent of x. So we know if we differentiate with respect to n, we will have here cotangent raised to the n of x times natural log of cotangent of x dx is equal to here pi over 2. So pi over 2, also here in differentiation we should multiply by coefficient of n. So here pi over 2, so here 5 square over 4, and derivative of secant, we know secant n pi over 2 times tangent n pi over 2. Well, now we have natural log of cotangent of x square, but here natural log of cotangent of x, so we can differentiate again with respect to n. So we can write now here 0 to pi over 2 cotangent raised to the n of x times now natural log of cotangent of x square dx. Okay, now we know this is equal to here pi over 4, so we should multiply by coefficient of n, so 5 over 2. So here now 5 raised to the 3 power over 8, and now we will have product of two functions, so we can use product rule. So first I am going to write secant n pi over 2. So secant n pi over 2 times now derivative of tangent, we know secant square of n pi over 2. So here secant square and here secant, so secant raised to the 3 power of n pi over 2 plus, then I'm going to rewrite tangent n pi over 2, now derivative of secant. So we know derivative of secant function, secant of n pi over 2, secant of n pi over 2 times tan of n pi over 2. So here we can write tan square of n pi over 2. Okay, then if you want you can take secant n pi over 2 as a common factor. So 5 raised to 3 power over 8 secant n pi over 2 times secant square of n pi over 2 plus tan square of n pi over 2. Well, now I'm going to take when n is equal to 0. When n is equal to 0, we know here this is equal to 1. So we will have 0 to pi over 2 natural log of cotangent of x square dx is equal to, now we know here when n is equal to 0, here 1, so 1 0, so only 5 raised to the 3 power over 8. Okay, this is the answer. If you like this video, please subscribe this channel. Thank you for watching.